Today's part 2 lesson is from 5.3. So the main part with this portion of the lesson is going to be, you can see on the first slide already, is that we have a bit more work to do to solve. Generally, we'll be substituting, factoring, things of that nature to find our solution. So starting off here, we got 2 cosine squared of x minus cosine of x minus 1. Now, this is very similar to how we would solve something like 2x squared minus x minus 1, right? Except for we've got cosine instead. So it's a quadratic form, so we can factor, right? 2 times negative 1 is minus 2. The numbers add equal minus 1, giving us a minus 2 plus 1. And so my 2 parentheses are going to be, first, we got to divide by 2. Sorry, jumping ahead. But we've got this 2 piece here, so we have to bring that back. And this negative 2 over 2 is minus 1. So I have 1 parenthesis of cosine of x minus 1. And then this other one is cosine of x plus half. But we don't really do the plus half. So we're going to bring the 2 back up and under to be 2 cosine of x plus 1. And now we set each of those pieces equal to 0 to solve. So we get cosine of x minus 1 equals 0, and 2 cosine of x plus 1 equals 0. Solving, I got cosine of x equals 1. And then I get minus 1 from both sides divided by 2. I get cosine of x is minus half. Now, they currently don't look like a pattern, but let's look at our points. So cosine of x equals 1 right here. That's our first value at 0, then 2 pi, 4 pi, etc. Color code a little bit here. In red, our other side, minus half, is going to be like these, which would be, let's say, that's 2/3 and 4/3. Right? So 2 pi thirds, 4 pi thirds, 8 pi thirds, 10 pi thirds, right, by adding 2, etc. So if I put these in order, we've got, I put both these sets in order to see if they have a nice kind of pattern to it. Looks like it might. We've got 0, 2/3, 4/3, 2 pi, which we want in thirds, so times 3 over 3, and we're going to get 6/3. Well, no, that was 2 pi. And then I got 8/3, and so on. So far, it looks like it has a nice pattern to it. We've got 0, 2, 4, 6, 8. And the bottom is staying the same as thirds. So this means, right, we're adding plus 2 pi, right, continually. And that was 3 bumps, sorry, pi, and so on. So we have this plus 2 pi thirds pattern going on, with our first one being 0. So, right, this is another one of those 0 plus 2n pi thirds. And then we just get rid of the 0. So our answer is going to be 2n pi thirds. Okay. Next, a little bit of a trickier one. So I've pre-done it, and I'll just kind of explain the steps here. When you first look at this, these are like dealing with x's and y's, right? Even though they both have sine squared of x, cosine of x, you can't factor when we have sines and cosine. So what you have to do is this sine, if we're squared, we're going to have to substitute 1 minus cosine squared in for that sine squared. So once we plug 1 minus cosine squared of x in for sine squared of x, now I'm going to distribute, right? Because the 2 doesn't belong to the 1 or the cosine squared. It goes to both pieces. So I multiplied both pieces by the 2 to get 2 minus 2 cosine squared of x. And then the rest of this equation just kept coming on down. Right? Plus 3 cosine of x minus 3 equals 0. And now combine like terms. I've got squares, x's, and now 2 minus 3 for my units. And I ended up with this in purple here, minus 2 cosine squared of x, plus 3 cosine of x, minus 1, right? That was from my combined like term. Now, generally speaking, we don't factor with a negative x squared. I would just multiply both sides by a negative 1. which is the same idea as if I added everything to the opposite side, right? Plus 2 cosine squared to the other side, minus 3 cosine of x plus 1 has the same exact field. So we can just multiply by a -1 or flip it to the other side. And so we end up with 2 cosine squared of x minus 3 cosine of x plus 1. And then we're doing 2 times 1 and factoring. Gives us 2. And what numbers add to equal -3? And we get the numbers again, -2 plus 1. And then we had to factor by simplifying. -2 over 2, because this 2 comes back in the picture under both pieces. -2 over 2 is -1, so that gets its own simplified. And then this -1 over 2 is -1/2 becomes cosine of x -1/2, and we slip that 2 back up to being the coefficient of that parenthesis. And then we get each piece equal to 0. So cosine of x -1 is 0, and 2 cosine of x -1 equals 0 to get us cosine of x equals 1, cosine of x equals 1/2. Now this one, drawing it, is cosine is 1 again, so that's 0, 2 pi, ... On the right side here, we've got cosine of x is +1/2, which is pi-thirds. And all students take calc, so down here, cosine 5 pi-thirds. So we don't have a great pattern here. It doesn't look like a pattern. You can try to write a couple out to see it, right? If you weren't sure, right? We got 0, pi-thirds, 5 pi-thirds, 2 pi, 7 pi-thirds, right? It's not a pattern, right? 1/3, 5/3, 6/3, 7/3. So what you're just going to do is we're going to have 3 separate answers, right? All the answers for this repeating, all the answers for that pi-third repeating, and all the answers for 5 pi-thirds repeating. Right? So we've got 2n pi for my 0 plus 2 pi answers. There's one set. My next set is going to be pi-thirds plus 2n pi. And my last one is going to be 5 pi-thirds plus 2n pi. So you won't always have a repeating answer in terms of finding a pattern like we did fairly commonly in the past problem and in part 1. But it can, right? The last problem had a pattern. This one, looking at the picture, these are not a nice rotation, right? They're not nice and equal. With 3 numbers, they want to be about 120 degrees apart. So that's usually like, what, 2 pi-thirds apart, and they clearly are. Moving on to a new type of problem, slightly. We've got solved the equation, okay? Not new, but we've got a limitation. We're looking for answers between 0 and equal to 0, less than or equal to x, less than 2 pi. So from 0 to 2 pi. Now this just tells us our answers are not going to be plus 2n pi anymore. Okay. Now we can use that if we want to find more answers, but that won't always keep us between 0 and 2 pi. So keep that limitation in your mind when you're doing this. Again, we've got cosine squared and sine. Okay, so generally speaking, we can change the cosine squared, right? So this one's going to become, the unit squared is going to become 1 minus sine squared x. Plus 1 equals sine of x. And again, it doesn't help us to equal a value, so we're going to subtract the sine of x from both sides. And then we're going to simplify. I've got minus sine squared x. We'll do the squareds first. Minus sine of x next. And then we've got 1 plus 1. Well, that's plus 2. Equals 0. Now, again, we've got a negative with a leading coefficient. It's just easier to flip all your signs. So then this is going to become a positive. The negative sine of x is going to become a plus sine of x. And the plus 2 is going to become a minus 2. And again, that was, we basically multiplied the whole equation there by a minus 1. Now we've got 1 times negative 2. And numbers that add equal plus 1. So those numbers are going to be positive 2 minus 1. gives us sine of x plus 2, in parentheses, and sine of x minus 1. Now, sine of x plus 2, set it equal to 0, and that's not going to give us a nice answer, because sine of x can't equal 2. Can't equal negative 2 either. So this one was a does not exist or a null set, right? So none, but the other answer can still work, right? Sine of x equals 1, sorry, minus 1 and 0 gives us sine of x equals 1. And now remember that this is the y value, so looking at, I just draw kind of the quadrant, we equal 1 right here at pi half. It is not plus or minus 1, so we just have that answer repeated, right? So x equals pi half. Now, we don't need the plus 2n pi because we're only looking for answers between 0 and 2 pi, right? So this time, it is just x equals pi half. It didn't ask for all solutions, it asked for all solutions between 0 and equal to 0 and 2 pi. Next, 2 secant squared of x plus tangent of x equals 2. Now, I believe I did switch the order here because the last one was a little bit of an oddball. So number 11 will be coming up in a second. But again, we've got a secant squared tangent. This is where you have to bring in your, sine squared plus cosine squared is 1, and x. I need secant and tangent, so I'm going to divide by cosine squared across the board. Each piece is going to get their cosine squared in the denominator. They give me secant squared equals tangent squared plus 1. And now when I see secant squared, this is going to become tangent squared of x plus 1. And then I'm going to move everything to the left side of the equation so we can solve. Okay, so then this 2 is going to distribute 2 tangent squared of x plus 2 plus tangent of x. And then we're going to subtract the 2 from both sides to get 0. Now we've got a plus 2 and a minus 2. So that leaves us with 2 tangent squared of x plus tangent of x is 0. They both have a tangent of x. So factoring that out by kind of the greatest common factor, we get tangent of x times 2 tangent of x plus 1 equals 0. And this leaves us with tangent of x equals 0 and 2 tangent of x equals minus 1. Tangent of x equals minus half. Now, this is not a unit circle value here. We're going to need our calculator to figure that one out. But tangent of x equals 0 is a unit circle value. So, tangent of x equals 0 at 0 and pi and 2 pi and so on. But we only want answers 0 to 2 pi, including 0. So far we got 0 and pi for our answer. Tangent of x equals negative half. We'll do in blue here. Negative half, right? We've got all students take calc. So sine in these two quadrants, quadrant 1 and 3, or sorry, 4, 2 and 4, can't talk here, are where tangent is going to equal negative. It'll probably be something like this and that. So we're going to need to use our calculator. We're going to have to do tan inverse of negative half gives us our x value. It will give us quadrant 4 negative, it will give us a negative 0 to pi half answer. That cannot be our answer. Okay? Quick flashback. Why not? This is 0 to 2 pi. It's going to give us a negative value for our quadrant 4 answer. Oops, sorry. I'm trying to skip too far back. Here we go. So we need to keep that in mind. This is where these kind of inverses get a little tricky. So tan inverse. Let's out the calculator here. We got tan inverse, second tan, of negative half. Notice, negative sign 1 over 2, not the minus. And make sure you are in radians. Because we've been dealing with pies, we're not all of a sudden in degrees. We get negative 0.4636. We round to the third decimal, so 4636 will be 0.464. So this is negative 0.464. So meaning this is 0.464 radians. And so we want to use our fact that pi is the period. So we're going to add pi to this to find our quadrant 2 answer. And then we're going to add another pi, technically adding 2 pi to what they gave us, to get our positive quadrant 4 answer. Okay, so plus pi, and we get 2.678, and then plus another pi to get 5.820. So 2.678 and 5.820. And now put all 4 answers together, so I'm not looking for your answers in weird spot. We got 0, 2.678, pi, 5.820. And putting all 4 answers in the same area generally works nice to go from least to greatest, because those were our answers for tan of x equals negative half, and these were the answers for tangent of x equals 0. Now the last question, in hindsight, should have came before that one, because it would have went over why we had to be specific about what quadrant our answers are coming from for these questions. So sine of an angle is negative 0.87, so we're going to do sine inverse of the negative 0.87 to get our answer. Now, it is going to give us an answer somewhere over here in the values probably close to negative pi half. Negative pi half is not between 0 and 2 pi. Okay? So, A, we've got to be a little smart here. There's more than one answer. There's going to be a quadrant 3 and a quadrant 4 answer. There's one part of it. And 2, we have to manipulate the answer the calculator is going to give us to be, to find the reference angle so that we can use it to find our quadrant 3 answer, and then use it one more time to find our quadrant 4 answer, which lies between 0 and 2 pi. So hop up the calculator again, second sine inverse, negative 0.87, get negative 1.055. So there's that. And now let's talk it through here quick. Negative 1.055 does not lie in this answer, right? But 1.055, the positive version of that, is our reference angle. As a reminder, reference angles are a little tricky, but I have two quadrants, all students take calc, where sine is negative. Quadrant 3 is negative, and quadrant 4 is negative. Quadrant 3 answers are pi plus my reference angle. Quadrant 4 is 2 pi minus my reference angle. So now using this 1.055, I just need to do pi plus the 1.055 to give me 1, my quadrant 3 answer. Just call it Q3, Roman numeral 3, and then 2 pi minus the 1.055. Really, we added 2 pi to the value our calculator gave us to give us the 0 to 2 pi version of the answer. Now plugging that in, again, we got pi plus, and we're just going to type it in because the answer key is going to give us the negative variety with one positive. So I get 4.197, and then we're going to do 2 pi minus the 1.05. So I get 4.197 and 5.228. And those are my 2 answers for sine equal to the negative, sine of an angle equals negative 0.87. And that wraps up today's lesson. Let me know if you have any questions.